Okay, to make sure that we make adequate use of Python and Python programming, we need to be able to abstract and generalize what we want to do for later purposes. And that's why we need functions. We need to be able to take routine tasks and turn them into functions that we can just use over and over again. So functions are a central concept in every programming language, and of course Python has its variation of functions. So let's cover some of the basics. So first of all, to define a function, you need to actually preface the function with the word def. So you say def space the name of the function and then the arguments. And we'll talk a little bit about the arguments because there's some intricacies there that we'd like to cover. And so once you do that, then you can then call the function later on. So let's go through a simple example here. So I'm going to create a function called pow, which raises a number to a specific power. Now, of course, we don't need to do this. Python already has a function that raises numbers to a power. In fact, it has an operator that does that when we just do double asterisks. But the idea here is just to show you what it looks like to create a function. So I do def pow, and then it takes on two arguments. An argument x, which is mandatory, and an argument n, which is optional, which takes the default value of 2. So when I put the n equals 2 into the function, that adds the default value for the function that if I don't call n, it will just replace it with 2. Okay, and then it has the, and then it's very easy to forget that semicolon. So just remember to put the semicolon after the end of the parentheses in the function definition. And then remember again that in Python, white space is meaningful. And so I've indented the return statement because that's part of the function. Okay, and so unlike most programming languages where we enclose our functions in curly braces or parentheses or something like that, in Python, it's the indentation that's doing the work for us. So in this case, the return is indented. And then we just simply say return x to the double power n. So now I could say pow, my function that I defined, 5, the first argument, so it's going to replace x of 5, and then 3, and it will return 125. So you can see, and then I put a print statement there because the Jupyter Notebook that I'm working in requires that. So just a reminder, our function has a mandatory argument x and an optional argument n, and the optional argument takes the default value 2, and so you can just put an equals 2 for whenever you want an optional value. So when functions have lots of different arguments, then it gets maybe a little less than clear how Python is calling them when you call the function. So here I give some examples. I do pow 3, 2, and then pow, and then I name the arguments x equals 3, n equals 2. And then I do pow n equals 2, x equals 3. And then I have a commented one out because this one throws an error, and I'll say why in a second. Pow n equals 2, 3. Okay, and all of those are doing the same thing. They're taking 3 and raising it to the second power. In the first case, I gave it 2 arguments, and since I didn't name them, it's going to go in the order of the arguments. So in my function declaration, right, x was first, n was second. So when I call pow 3, 2, it's going to set x equal to 3 and n equal to 2. And then if you have multiple arguments, it's going to go in the order that they are listed. Okay, now the next one, x equals 3, n equals 2. Now I've actually named the arguments. That forces Python to say, okay, it's specifically the argument x that I want to set to the value 3, and it's specifically the argument n that I want to set to the value 2. And then when you name all your arguments, you can then switch the order, right? So then I can say, like in the next line, n equals 2, x equals 3. because Python isn't getting confused then. Where it doesn't like is like that third line where I name the first argument, I name the second argument and put it in the first position, and then put an unnamed argument in the second position. And I think you could argue that maybe Python should be able to figure this case out. However, the point being, don't get too cute with doing this. When in doubt, just name all your arguments if you're in a concern. And then also, even if you're naming your arguments, try and keep them roughly in the order that the function declaration demands, or the function declaration gives, right? So if your function is a regression function and its predictors then response, tend to call it, even if you name both arguments, still call it predictors then response. I think that's just kind of generically good practice. Let's talk just a little bit more about some more advanced function usage. Not too advanced, but just a little bit. So we can have variable length arguments. And here's an example of a variable length argument. So you're just going to use the argument asterisk args. So here's an example when we might want to do something like that. Suppose I wanted to make a concatenation function that takes in as many strings as you'd like to give it, and then it concatenates them together. Now, of course, we don't have to do this. It's relatively an easy thing to do in Python without defining our own function. So once again, you have to squint your eyes a little bit about the utility, and then just think about the way we're using a function in this case. So in this case, I want to concatenate A, B, and C, and when I call that without calling a separator, it's going to automatically separate them by my default separator, which is /. So I get A/B/C, and then I could, of course, add a fourth argument, a fifth argument, and so on, because it has variable length arguments. And then now if I wanted a different separator, I would just need to name the separator at the end. Okay? So once again, they're just showing don't get too cute with mixing up your arguments. Now, if I did A, just think about this little pop quiz here. If I did A, B, comma, sep equals colon, comma, C, what would happen? Maybe try typing that in and see what happens in that case. Okay, but that's not something you would want to do, but what happens in that case? Try typing it in. Okay, the last thing I'm going to talk about with regard to functions is a really useful little function that at least I use all the time, and it's called lambda. And lambda gives you the ability to just create quick one-line functions. And so often you use lambda when you want to pass a function as an argument to another function. So let's just take, focusing in just on the return statement here. Imagine if I just typed lambda x double power to the 4, let's say, then that would create, and if I define that as a variable, that variable would then be a function that takes in one argument x and raises it to the 4th power. So there I can create a function in one line using lambda. So and it takes the syntax lambda x, so lambda of the argument, and then the function associated with it typed right after the semicolon. Okay, so let's write kind of a weird function, but let's think about an example usage of lambda here. So I want to define the function makePow n, and what this is going to do is it's a function that makes a function that raises numbers to an arbitrary power. So I define makePow n as that it returns a function that raises the argument to the nth power. So my makePow is a function that returns a function. Okay? And so if I were to say square equals makePow 2, and then if I were to do square of 3, gives me 9. Okay? If I say cube is makePow 3, then print cube 2, that's going to raise 2 to the 3rd power. So just then makePow is taking a argument, which is an integer, and then creating a function that raises an argument to that power. So that's an example, maybe a little bit intricate of an example of using lambda, but that's the kind of idea of using lambda, where you have a simple one-line function that you want to create, maybe often as a part of an argument to another function. Okay, so this should get you started on using functions in Python, and I think there's no better way to learn this stuff than to start trying it out. So I hope you try writing a couple of functions, and I'll see you next time.